This video is for Year 9 students that have chosen Year 10 General Maths next year. Linear equations, linear relations, linear modelling, linear inequalities, all sorts of linear stuff is really important in terms of general maths. Basically, you'll do a topic. The first topic of Year 10 is linear. The first whole term of Year 11 is linear related things, and a whole module of Year 12 further maths is also linear related. So it is very important that you sort of have some understanding and some confidence in linear, and we think this will help you when you move into Year 10. So we're starting with linear modelling, and previously when we did our linear topic, we did a whole document of linear modelling examples. So I wanted to just quickly show you in your OneNote. It was just before we went into lockdown and we started working on this in class, and then we had to go into lockdown, and we finished this document when we were in lockdown. So it'll be in your OneNote in the linear section. My class is called Linear Algebra and Equations. I'm not sure what your other teachers called it, but it'll be in the linear section that you did in your OneNote. So I want you to find that document because that'll be a good reference to use to help you to do these modelling examples that we're starting with today. So the document you have is a hard copy of this same little document I've got here. So the first example is looking at the progress of a plant's growth. So every day the plant is growing at a particular rate and starting at a certain point. So you can see there the height of the plant is referred to as h. The number of days of this experiment is referred to as n. And we need to write a linear model that represents this situation. So you can see there we're tracking the progress of a plant's growth. Today the plant is 5 centimetres high. The plant grows at 1.5 centimetres per day. Now we want to write a model, a linear model, that represents that situation. So we're talking about n days and h being the height of the plant. So really what I want to know is the height of the plant is, and have a rule for that. So I would have my rule, height is equal to 5 centimetres plus 1.5 centimetres per day. Okay, so pretty easy to write that sort of a relation there. Your calculator, remember when you're using the calculator on the graphs page, doesn't understand h or n. Okay, your calculator will have the function notation f of x is equal to, and your calculator only ever understands x. Okay, so when you're putting this into your calculator, you'll type in 5 plus 1.5x. So let's go on to the calculator and have a quick look. I guess it's a good thing, but the calculator is to be used for every assessment task in general maths from now on. So when you're doing your calculations, your assessment tasks, anything now that you are assessed on in general maths, you will have a bound reference and a calculator at all times. So you need to become good at using it. So let's open a graphs page, and you can see there function notation f of x equals, we're going to type in 5 plus 1.5x and have a look. So I can't see enough of the graph here, I'm not happy with that. On my document you'll see that the number of days, the bit of the graph that I want to see, that I'm interested in, is from day 0 to day 20. And the bit of the graph that I'm interested in terms of the height is from 0 centimetres up to 40 centimetres. So what I want to do is make my calculator screen look like my booklet. So I can, if I want to, click and drag my axis, or if I want to do, if I'm not happy with that method, I can hold my cursor over the numbers on the x and y axis. Once it says the word text, double click, and you can type in edit 20, enter. Same thing, hover over your axis number there, double click, edit to 40 and hit enter. So now I can see on my calculator what I can see on the paper. So that's useful. The one way that's really nice to be able to draw a graph accurately on a piece of paper from the calculator is if I use the table of values function. So if you go Control T and hit both keys at the same time, the blue control key and the letter T. So Control T gives me a table in there, and you can see I can scroll up and I can scroll down. The bit of the graph I'm interested in is when days are from 0 to 20. So what I'm really being shown here is my X value on my calculator relates to my N value on my paper. And when day 0, height is 5. Day 1, height is 6.5. Scroll down a bit, day 5 is 12.5. Day 10, 20 centimetres, and so on. So it's basically the whole table of the whole number values for both height and day. Okay, so if I'm going to put this graph accurately onto my paper, if I've got a couple of accurate points on there, I can easily put a ruler between and join the dots. So if I have a look there, when N was 0, height was 5, and when N is 10, height is 20. So there's two nice points I can put on my graph easily. So when N was 0, height was 5. And when N was 10, height was 20. So I've got two accurate points there. And then it really just means all I need to do now is take a ruler. So don't try and do this by hand, but grab a ruler and accurately put your line in there, joining the two dots. So it's pretty easy to do that when you're using that table of values function on the calculator. So what's the gradient? Interpret the gradient. What's the vertical intercept? Interpret the vertical intercept. So a really important concept in general maths is to be able to interpret what you find. So a lot of questions involve what's the answer, and that's easy enough to get off the calculator normally, and then interpret what you're finding. So in other words, in English, related to the context of this question, what did you find? Okay, so when you're looking at this one, what's the gradient? What's the y-intercept? So our rule up here was height is equal to 5 plus 1.5 n. So two numbers there that we're interested in, 5 and 1.5. They're my two values. One of those numbers relates to the vertical intercept. One of those numbers relates to the gradient. So it's pretty easy to see which one's which. The gradient is the one that is attached to the variable, and the y-intercept is the one that isn't. The y-intercept is on its own. So basically, when you're writing your answers here, what's the gradient? We often refer to the gradient as the slope in general maths. What's the slope of this line? 1.5. What's the vertical intercept of this line? 5. Now, if you were in methods and we asked you for the vertical intercept, you'd have to write 0, 5 in a bracket. When you're in general maths, we ask you what's the vertical intercept, we would accept 5. Okay, so there's little differences as we go through, you'll see. Interpreting the gradient and interpreting the y-intercept is two other skills. So basically what that 1.5 is related to is the rate of growth. Every day that plant grows 1.5 centimetres in height. So you need to write something that relates to the story. So we'd say something like, for every additional day, we expect the plant to grow 1.5 centimetres. When we're interpreting the vertical intercept, what we're doing is saying, what does this point here mean? So we know two things about it. We know when n is 0, height is 5. So n equals 0 means basically day 0, no time has gone past, no time has elapsed. So we're saying when number of days is 0, we expect the height of the plant to be 5 centimetres. So not very hard, but important. So interpreting the gradient and interpreting the y-intercept, really important aspect. Even in year 12 we ask that. That's on every exam ever, still, even at year 12. So they do expect that you can accurately and easily interpret both gradient and y-intercept. The height of the plant after 20 days. If your graph was really accurate, you could read it off the graph. I'd be more inclined to go, I wouldn't be too trustworthy of my graph there. I would look here, I could look at my table and I can scroll down to day 20 and say when number of days is 20, the height of the plant is 35. So that's a nice way to do it. I'll show you a couple of other ways also. So we know the answer is going to be 35 centimetres. We've already seen it on the table of values. But if you don't like the table method, not that one. Let's go back here. The table method, if that's not your thing, go on to a normal calculator page. You do have to take note of what your graph is called. Okay, so my graph is called f1 of x. If you've got a number of other graphs in there, yours might be called something different to mine. But f1 of x is what mine is called. So if I go on a calculator page and I want to know the height of that plant when day number 20, I could just type in f1, and you can see it goes bold because it knows that f1 relates to a rule that's already memorized in there. And I want to know f1 when the day number is 20. Okay, so what's the height when the days is 20? When I hit enter, it tells me the height is 35 centimetres. So I can do it that way quite quickly also. The other way we can ask the question as well is how long would it take for a plant to get to a certain height? And in this case, we're asking what's the amount of time that needs to go by? How many days will it take for this plant to get to 29 centimetres? So again, if you like the table method, you can scroll and be in the height column and scroll till you get to 29. There it was. 29 centimetres means day 16. Okay, so that's one way you can get there. If you wanted to do it on the calculator page using this sort of function notation, we would have to say, well, we already know the height, but we don't know the n. Okay, so we're going to have to solve this time. So you can say solve f1 of x equaling to 29, and we want to solve that for x. Okay, so solve the rule equaling to 29 when x is unknown. Okay, so if we do it that way, it tells us x has to be 16. If you're not a fan of the function notation, but you still want to use the calculator page and use solve, you can type in the whole rule there and go solve 5 plus 1.5 n, if you want to use n, equals to 29, comma n. And it will tell me the number has to be 16 to make that rule work. Okay, so there's lots of different ways you can use the calculator to get to the same answer. So basically, we've done it 3 different ways there, and you can see 16 days to get to 29 centimetres. So we can pop that in there also. So 16 days. Now, if this was a 1 mark question, 16 days is all you need to write in there. If this was a 2 mark question, you do need to say, what did you do? Okay, so you might need to write in the equation, what would you write? 5 plus 1.5 n equals to 29, and then n equals 16. Something like that would get you the working mark, the method mark, plus the answer mark, 16 days. Okay, now I'm not going to do any more today other than point you in the next direction to the next couple of examples. So there's plenty of examples to go on with, different situations, different stories, but similar kind of ideas. So there is heaps of questions there for you to continue with, and as I said at the start, you will probably want to pull out that reference, which was your linear modelling examples that you've done previously. So there was a booklet you had previously with 6 other examples in there. They'll be very valuable reference for you.